All right, this is our last rule, is the power rule. So what happens if we have an exponent on top of an exponent? All right, let's see if we can come up with a pattern. So x to the third, just remember that's just x times x times x. We write it multiple times. So what happens if we have something like where the base has another exponent? Well, remember, it's the same sort of thing, right? We multiply x squared by itself 3 times. So that would be like x squared times x squared times x squared. And now we know this rule: if we're multiplying like bases, then we add all of these, right? 2 plus 2 plus 2 is 6, so x to the 6th. If you wanted again, you could expand those individually, and we would get x times itself 6 times, okay? So same sort of thing. All right, let's do another example. This would be x to the third times x to the third 4 times. Okay, again, we could use either way. We can expand again, or 3 plus 3 plus 3 plus 3 is 12. So what's the pattern? What do we see? We have a 2 and a 3, and it gives you 6. We have a 3 and 4, and it gives you 12. So hopefully you're getting what happens is you multiply their exponents. So when we have a power or exponent, power to a power, or exponent on top of an exponent, with we multiply them. So an example would be like x to the a to the b would be the same as x to the a times b. Okay? All right, so if we were to expand this one as well, we would have 2x squared times 2x squared. So that would give us 4x to the 4th. Okay, so if you want to use the rule here, again, we multiply those together. Another thing is we multiply those together, okay? So that would give us 2 squared and x to the 4th. So that ends up giving us that 4x to the 4th. Okay? So we're squaring, I should use a different color, we're squaring everything that's inside. We're squaring the 2, we're squaring the x squared, okay? All right, so let's do a few examples together. This is going to be a short one today, all right? So power to a power, we multiply. So that would be x to the 12th. Super easy, okay? Pause anytime to give these a try. So what would this be? Well, that would be x to the 2 times 7, or x to the 14th. Okay, these ones are a little trickier. Just remember that everything in that parenthesis is squared. So that's 2 squared, and it's also x to the 3 squared, so that's 6. So that would give us 4x to the 6th. Okay, so we're squaring everything that's in there. Here's another example. So we're going to square -3. Again, if you prefer, you can expand these. Sometimes I feel like a power to a power sometimes is leads maybe to expanding, but you could do -3y squared times -3y squared. And then we can evaluate. So -3 times -3 is a positive 9. And then y squared times y squared would give us y to the 4th. Again, we add those, not multiplication. Okay? Or if you preferred, you could say we're going to do -3 squared and y squared squared, and do those individually. So lots of choices. That gives you 9 and y to the 4th. Okay? Lots of choices. Okay, so here we'll try a couple others. Again, I recommend that you pause and give it a try. So we multiply them. So that's x to the -24th, but we don't want negative exponents. So then we would need to say, well, this is our coefficient, that's going to stay, and then this goes to the bottom, and we change its sign. All right, we have a power to a power, but it's to the 0, so everything is to the 0, which means that this is just 1. If you wanted to, you could say, well, that's 5 to the 0, and x squared to the 0. Oh, sorry. But that's 1, so we just get 1 times 1 is 1. All right, last two. Again, we probably want to do the power or the exponent on top of an exponent first before you try and do anything else. So we'd evaluate that first. So that's x to the 8th times x. Again, that's like x to the 1. These are being multiplied. So we add their exponents, so that would be x to the 9th. All right, again, simplify the numerator or denominator first. So this can't really be simplified, but we can evaluate that. So that's 3x to the 7th over x to the 6th, because we multiply those. And then now we're using the division rule. We subtract their exponents, so we'll subtract 6. And start with the largest, subtract the smaller exponent. That cancels out. It's just x to the 0 or 1. And we would get 3x to the 1, or just 3x. All right, last thing is using that rule when we're using like area. So area of a square is the length squared. Okay, it's length times width, but length equals width. So we can just say it's the length squared. So if we want to find the area of a square, well, the area is just going to be our, like this could be our length, will be x squared y to the 4th, but we'll square it. So it's kind of the same thing that we were doing above. All right, so we're squaring x squared, so that's x to the 4th, and we're also squaring y to the 4th, so that would be y to the 8th. Again, you could expand it and do x squared times y to the 4th times x squared times y to the 4th, and you end up getting the same thing. So why don't you give this a try? Again, area is going to be equal to that squared. So it's going to be 6 squared and x to the 8th squared. So that's 36. X to the 16th. All right, so I think that's it. If you have any questions, please let me know, and we'll see you later.